After the design, the second most important factor in the maintenance and operation of these types of devices is maintenance. These devices need to be maintained on a regular basis, hopefully quarterly, so that they can always perform at their peak capability.
Our job as inspectors for the District Department of the Environment is to go around and look at these devices and make sure that the owners are doing their job and living up to their maintenance responsibilities for keeping the device in good working order. First order of maintenance would be to remove all of the trash that's accumulated in the facility over the past year since it's been maintained since the last time. The good news is all of this trash and debris and sediment and grit that would have normally gone into the river are all trapped right here in this bioretention area in the inlet as well as in the bed area. One of the maintenance issues with bioretention areas are the inlets. If they're not clear and cleaned out regularly, then it presents a problem because they clog up and the water bypasses. A little area that's starting to be cut away due to a concentrated flow of stormwater that's come down the hill and hit the curb and run into the curb cut inlet as it's designed to do. But once it's gotten to the stoneware, the concentrated flow of water has begun to cut a rill right through the bank of the stormwater pond. So therefore, it would need to be addressed by either creating a larger, more robust stoneware or backfilling the area, or probably both. This is some of the bad things that can happen at bioretention cells. We have a problem here with earth slippage where the banks are somewhat steep, and this is one of the problems that can occur with bioretention on some sites. And as a result, we have a large slippage here and cut of the soil. And the soil is kind of an unstable soil, so we're going to have to rebuild it. That ensures that it doesn't continue to cut and fill in the bottom part of the bed. Also, a thing would be to remove volunteer weeds like this locust tree that started to grow, and to cut off the overgrown plants that were planted in initially.
Now these plants have been here for a couple of years now, and you can see they're actually in very good shape. There's not a lot of dieback, lots of good buds on the stems. But what we want to do is check and just see how the roots are growing and make sure they're not bound up or there's too much clay around the root system that would prevent them from spreading out and really growing well. So what we do is just dig a very small hole around the root base of the roots and take a look and see how the roots are coming out along the plant. You can see here they're very fibrous and they're really expanding out from where the root ball would be. So that really shows that the plants are really growing nicely and have a good chance of long-term survival.
Rain from this large apartment complex drained directly to some bioretention on this location. There were two problems on the site. First, the under drain was completely clogged, unable to drain water adequately. 2, all the plant materials were dead and they needed to be replaced. 3, inadequate mulch and they had to be replaced.
We're taking care of one of their bioretention ponds. What we've done to start with is opened up the overgrown vegetation that had basically taken over the bottom of the pond here, leaving the desirable natural plant material, and most importantly, opening up the inflow feature from storm drain into the pond where the bioretention pond does its job. You can see how the silt has built up around the former existing rock bed here. That's all going to be cleaned out, and then we're going to be adding additional stone to help do two things. Number one, convey the water in the direction we want it to go, and number two, deflect the force of the water to where it disperses more effectively throughout the pond bottom. You can see the amount of trash